Hi, my name is Eric Espinoza. I am a part of the COMPSCI-3 class, and I will be going over Project 5 instructions and registers. With respect to how a computer works by using vital components such as Boolean algebra, logic gates, logic circuits, and the CPU. Boolean algebra is basically a foundation of how a computer works. It's a type of algebra that we use with logical operations and binary variables that have three different types of operations: the and, the or, and the not operations. It's useful for developing the circuitry that goes through the logic gates. And the properties of Boolean algebra are associative, identity, commutative, annulment, complement, idempotent, sorry, distributive, and De Morgan's law. So these groups of terms are the processes, the operations that make up Boolean algebra expressions. And those are the product terms, sum of terms, min terms, sum of min terms, sum terms, product of sums, max terms, and product of max terms. Now, logic gates are physical devices that utilize Boolean algebra to carry out operations. Essentially, they're expressed with zeros and ones, ons and offs. And they have up to two outputs, but only use typically one output, which is going to be true or false. Again, the on or off symbol. And they determine based on the inputs whether a signal will pass or not. To understand how logic gates work in a computer, one must be familiar with concepts such as current and voltage. So the basic logic gates, again, are and, or not. And then in expression to those as well is NAND, XOR, NOR, or XNOR. Now, logic circuits are circuits that execute logical operations on input signals. So logic circuits execute the functions that are being processed and controlled, and the outputs are based onto its inputs. Logic circuits fall into two categories, which are combinational and sequential. A combinational logic circuit's output only depends on inputs at a very specific timing. And examples of a combinational logic circuit are adders, converters, and others similar in that fashion, etc. A sequential logic circuit's output depends on both current and past inputs, and an example would include registers, counters, clocks, and flip-flops. Now, a CPU works essentially in this respect. It is responsible for program control as well as processing binary information. The CPU is the main component of a computer as it manages all operations, and it consists of a program counter, L1 cache memory, instruction register, control unit, registers, arithmetic logic unit, bus interface, and condition flags. So the program counter is also known as the instruction pointer. It is responsible for holding the address of the following instructions in queue. The L1 cache memory is the quickest memory within the CPU. It's like instant access to quick storage. The instruction register functions as storage for a set of instructions that are being executed in current time. And the control unit controls the timing of the operations and generates the signals sent around. Now, the bus interface is actually responsible for fetching the instructions and other bits of data, whether it is from output system or something within the computer itself, and it collects the data for the CPU and also kicks it back out. The condition flags are a bit of a status register that holds the responsibility of illustrating the outputs from the operations performed due to the arithmetic logic unit, ALU. Now, the CPU interacts with memory in the sense that the CPU essentially communicates to the memory for data and instructions. So the CPU interacts with memory and subsystems through data, addresses, and control buses, or essentially, again, the bus interface. The control unit sends the instructions to the memory by loading the instructions onto the address bus and places a copy onto the data bus and signaling right on the control bus itself. Now, lastly, the CPU executes programs through the instruction execution cycle. So, the instruction register is a particular component in the CPU that allows it to execute programs, where it itself determines the CPU's next course of actions based on the bit pattern. So, the control unit is responsible for executing the programs itself. And to execute the programs, the memory addresses of the instructions is copied from the instruction pointer register onto the instruction register itself. These instructions are then saved onto the memory, And the first instruction's memory address is then copied into the program counter. And the CPU fetches and sends the address from the program counter to the memory, and the copy of the state of the bits is delivered into the data bus by the memory. So the CPU copies the states of the bits onto the instruction register, which is followed by bytes being added and the instruction being executed. And essentially, that is the way a computer works. Here is the works cited. I will leave that for a second, and you're more than welcome to pause to view the additional information. But other than that, it was a pleasure to walk you through how a computer works and going over the instruction and register system.